am super excited to welcome Phil Nelson from OpenCV. Yes, the same folks that brought you the amazing contest from Ignite. Phil, why don't you introduce yourself and tell us a little bit about some of the contests y'all have been running?
Yeah, thanks for having us, Seth. I'm Phil Nelson. I'm the Director of Content and Creative at OpenCV. We have done quite a few contests with our friends at Microsoft and Intel. The most recent one is OpenCV Spatial AI Contest, but before that, folks might have seen OpenCV AI Competition 2021, which was this massive global contest. They would have seen the highlights at Ignite, of course, and it really inspired us. In fact, one of the winners inspired us to launch this next competition.
So tell us about this next competition. This is your third contest with Intel and Microsoft, and you've seen a lot of submissions. If people want to win these kinds of things, what tips do you have for making a good submission to these kinds of contests?
Great question. We get this from people that submit all the time as well. And what we see a lot of is people really zoning in on the problem domain that they're trying to solve or help in, but also really thinking through what tools they'll have available, who will be able to work with them, and really drilling down and simplifying their pitches to the most basic parts, and then just going to town and building them over the course of the contest.
This is different than a regular hackathon, because back in the pre-days, like I like to call them, we would sit down for 24 hours and do like a hackathon. But how do you keep developers interested, engaged over a longer period of time with these kinds of projects?
Yeah, it's difficult sometimes to even know, especially early on in these contests when teams are just getting started, if they're doing well or if they're struggling, unless you really engage with them on the stuff that's available to you. We use Discord. The Luxonis Discord is really active, and there's always people there helping each other out. One of the great things about it is that sometimes there'll be a question asked, and I'll be reading it and get ready to answer, and then realize it's already been answered by somebody in the community. So the Discord has been great. Our Opencv Newsletter is another great way to keep involved with everybody. And the teams that join these contests, we have a separate newsletter, and we'll send communications to them, reminding them of the deadlines, giving them some best practice info about, here's the best way to post stuff online, show people what you're working on, build a little groundswell of public support.
I mean, this is really cool. So 2 things before we give you the boot, and I talked to some of the folks that have won the contest. Tell us about the contest this time, and then also tell us about the winners this year.
Yeah, so OpenCV Spatial AI Contest this year, we had about 150 submissions. We selected that down to 50, and they spent the last 3 months building these projects, and we were really blown away by the quality of the final submissions. Our grand prize winner, Team ICANN Reborn, with their project ScanNerf, which takes the concept of 3D scanning and brings it into the era of the metaverse. And our second place team, Uca Robotics, built this really impressive human-computer collaboration tool during the contest. And in third place, we had Team Potato Lovers with my favorite project title, the Colorado Beetle Buster.
Anything with the words Beetle Buster gets an A in my book. All right, well, I'm going to kick you off. Let's go to the winners right now. All right, we have the first set of winners, ICANN Reborn, Federico and Damiano. My friends, tell me something interesting about your team. We'll start with you, Federico.
Okay. Our team is composed by 8 guys, 6 from ICANN, like me and Damiano, and 2 from the University of Bologna. ICANN is a startup that deals with robotics, computer vision, and deep learning. One fun fact about this project and the team was the difficulty that we had to share the data that we recorded during the project. In fact, we scanned a lot of objects, and we had hundreds of gigabytes that we had to share to train all the NERSC models.
I mean, this is awesome. Now I'm curious, because you're talking about models and a ton of data. What problem were you trying to solve? We'll go to you, Damiano.
So we basically wanted to take a step further into the creation of the metaverse. With our project, we can create a neural twin of a real-world object in just a few minutes, thanks to our scan station, as it was shown as it's shown inside the video. Our scan station is able to generate a dense dataset of a real-world object, and these datasets are suitable for neural radiance fields, NERF models. And this is useful because all the available datasets now for NERFs are both or synthetic or with not enough images, while our datasets are composed of thousands of images. The scan station is composed of a robotic arm, which takes photos at different zeniths of the object, while the object is located over a rotating base with a cherub on it to capture the azimuths instead.
I mean, that sounds awesome. So you're basically building a neural digital twin that goes into the metaverse automatically. You mentioned some of the stuff that you're using. Federico, can you get a little bit more into how the process works?
Yes. So after we built this robotic arm, what we have to do is just to place the object we want to scan on this base. After all the pictures are taken, we compute the camera poses thanks to the Cheruko marker that is placed on the base. Then we compute the pixel-wise masks for each image. And then we use these images to train a NERF model. And then we are done.
I mean, that's interesting, but are these just regular pictures? How are you getting the pictures?
Our pictures are taken with the HawkD light and with the library Depth AI that helps us to record many images in just a few minutes.
That's amazing. So, Damiano, we're going to be looking at a demo of this coming up next. Can you tell us what we're going to see?
So basically, we will see the object located over the base of the scan station, while the arms goes down, taking pictures of the object. And then after taking all the photos, we have our data sets, and we can, from the data set, create the neural twin where we're going to see on the video.
Well, that's fantastic. So let's go to that video right now. I'm excited to present second place winners, Uca Robotics. Francisco, tell us about your team and what problem you were solving.
Hello. We are a 3-people team. We work in the University of Cádiz in the south of Spain, and we are part of the Applied Robotics Research Graph. And our background is about rehabilitation robotics and computer vision for industrial robots. The problem we wanted to solve in this contest is about safety in human-robot interaction when the robot and the human are working in a shared workspace.
I mean, that's super important topic. How did you go about solving this problem?
Yeah, what we did is to use 2 cameras. One camera is for human interaction, for human-robot interaction. So we can measure the distance from the person to the robot, and we can change the behavior of the robot depending on this distance. We also recognize the face of the person in order to know if this person is authorized or not to be near the robot.
I mean, that's really cool. I feel like I want to see how this works. Can you show us how it works?
Yeah, I think we can show you some experiment now.
Let's do it.
What you see here is all the information we are sharing in our system. So you can see the pictures of our two cameras, and also you can see the robot in the ROS environment. So what we are going to do now is to move the robot only with the movement of my hands. Okay, so I'm gonna start. So I'm gonna put my hand, and the robot now is going to follow my movement. Okay, so if I move one side, the other side, and we can try to perform a grasp. Okay.
That's cool.
Perfect.
So basically, it's looking at the 3D point cloud. It's finding out what gesture you're making, and it's following you around and doing whatever gesture you want.
Yeah, well, we are using different neural networks in order to detect the hand and also the gesture you are doing with your hand.
That's fantastic. What else is this robot doing?
Yeah, we can also do some kind of assembly task.
Okay.
And we have here 3 parts. And you can see in the 3D point cloud that we have three green spheres. These green spheres means that the parts are in the correct order. If we change the order, we can see that now we have 2 red spheres. So these 2 parts are not in the correct order. So one thing we can do is to learn to teach the system that this is now the correct order. In order to do that, we can use one gesture of the hand like this, which is an L. So now we can see that the 3 spheres are green. So now this is the new order. So if now we want to take this kind of parts, we can tell the robot that we want, for example, the second one, which is the blue. Now we tell the robot we want the second part. So now he's taking the blue part.
That's really cool. And that's after you switched it. It learned which one was the right one, which is really cool.
Yeah, now the right one, which is this one, we know this is the first part of the scene. So we can see, give me the first. And now the robot is giving the red part.
Oh my, that's really, really cool. So you also mentioned that there was this part where it recognizes authorized people. What was that feature all about?
Yeah, now you can see that in the picture, I have in my face a green square. Mm-hmm. This is because I'm authorized. Now, a colleague is going to sit in front of the robot, and he is not authorized. So if he sits in front of the robot can see that he's not authorized, and he cannot do anything with the robot. If he wants, for example, one of the parts, the robot is not doing anything. Okay? So now he is out, and I'm going to sit again. And now the robot, in a few seconds, but now it's okay. Now he knows that I'm the person. I have the first, the second, and the third, and he's giving me now the third part, which is the only one, the last one.
Well, Francisco, this has been absolutely amazing. Thank you so much for your time, my friend.
Thank you.
All right. I'm excited to welcome the 3rd place winner, Potato Lovers. Michael, tell us about yourself and your team.
Hello. Hey, I'm glad to be here and represent our team, Potato Lovers. We are from Poland. My name is Michał Rzepka, and I'm software developer. I do love prototyping devices, and I have networking background. The second member of our team is Marta. Marta is an accountant. She has no IT background, but she is passionate about new technologies. We both love healthy food. That's why we decided to take part in the competition and to share our idea.
That's awesome. I also am a food lover. What problem were you trying to solve, my friend?
So our idea is to reduce amount of chemicals which are used in farming. So we are focused on protecting potato fields where insecticides are used against Colorado beetles. Colorado beetles are small bugs which destroy potato fields by eating potato leaves. What we want to achieve is to detect Colorado beetle with neural network and spray them pointwise. That would reduce amount of insecticides significantly.
That is super cool. So basically, instead of just spraying an entire field with insecticide, you find where the insect is and you're like, not this time. And you're doing that with neural networks. So can you describe a little bit what solution or what tools you use to solve this?
Yeah, of course. The most important part of our project was to train our neural network. So we feed our network with hundreds of images to get the satisfying result. Our network runs on OGD light camera and notifies the robot if the Colorado beetle is detected. The OGD light camera provides us also deep image, which we use to localize the detected objects. The second challenge was to create a robot. We needed a vehicle which was able to run along the potato row and aim to the object with a spray gun. And another task was to create a spray gun for point-wise spraying. For that purpose, we used a low-voltage water pump, which was powered by electronic circuit designed by us. And all these peripherals like OD light camera and spray gun are connected to microcontroller. And the microcontroller is the central unit of our project, which receives information about Colorado beetle detections and deep image from the OD light camera and control the vehicle. So it's also responsible for translating coordinates from the camera perspective to the robotic arm perspective.
That is so clever. So there is literally a little robot that's driving across the potato fields, looking to see where the bugs are, and then actuating a spray to just get that bug. Is that right?
Yeah, exactly.
That is amazing. I understand you brought a video with us to show us this whole thing in action. Can you describe what's in it?
Yeah, of course. On the team, we're going to see our robot running along the potato row, detecting and spraying spotted Colorado beetles just when
That's so cool. All right, well, let's go to that video right now.
Hello all, I'm Marta.
And I'm Michał.
We are potato lovers.
Our goal was to significantly reduce the amount of insecticides used to protect potato fields.
And we would like to present you our project, Colorado Beetle Passer. Our solution provides us a vehicle with a robotic arm. OGD light camera is mounted on the top of the robot and provides us a Colorado beetle detection and deep image, which we use to calculate Colorado beetle coordinates. The center of the robot is the Raspberry Pi, which controls OGD and the spray gun. The spray gun is mounted on the top of the robotic arm and is supplied by the low-voltage water pump. The water pump is powered by the electronic circuit designed by us and controlled by Raspberry Pi. Okay, so let us see how it works.
So just a self-serving question, Michael, did you use Azure or what other things did you use?
Yeah, exactly. During the training process, we used Microsoft Azure, Opencv Toolkit, and Luxonius examples. These tools simplified and speeded up our work a lot and made the whole process so easy.
Amazing. Phil, those were really cool projects. I've heard that there's still one winner left, though, to be announced, and there's a special way to get that winner. Can you tell us how that works?
Yeah, that's right. So we've got the popular vote this year, as we did in the previous competitions. And this voting will be open to the top 10 teams, which you can watch all of their final submission videos and choose your favorite at opencv.org/vote. By doing so, you will also be entered to win one of 5 free Oak D lights.
Ooh. So it's like a People's Choice Award kind of thing.
Exactly. And we'll be running this through Build.
Oh, fantastic. So make sure you go to that. Just a couple of side questions, because I know people are watching this and they saw those cool projects that were built and they're like, should I really get involved? Why are these types of things really awesome for developers?
These contests are great for developers because they really let you put your foot in the door, so to speak. We've heard so much from people for this competition and even in previous ones that this was the first time they'd ever used AI or computer vision, and some of them were big prize winners both times. One of the great examples of this is our friend Paula Ramos, who participated in 2 previous contests and now works at Intel being an evangelist for OpenVINO.
All right, Phil. So if people want to stay up to date and they want to know when the next contest is going to happen, how can they do that?
Great question. Easy answer. Go to opencv.org/newsletter and sign up for the newsletter. We'll tell you as soon as we have information on all that good stuff.
Fantastic. Any final words or anything you want to say?
Just want to say, hi, Mom. I love you.
Hello, Phil's mom. We all love you. If you would like to learn more about Intel OpenCV, the contest winners, basically everything, make sure to head over to the Intel partner page on the Build site. I will see you there.